Hello everyone, welcome back to the channel. Today we are keen on understanding one of the most important Kubernetes concept, that is a pod object. So in the previous session we have seen single container pod, but in this session we will focus on multi-container pods. So in this image, in the right side we have a pod manifest file template. The same code can be executed in this session. So I will show you how to create pod with the multi-containers. Okay. So pretty much every Kubernetes interview, a real-time project or production issue starts. Why? Because pods are the smallest deployable units in the Kubernetes. So eventually, if you understand pods clearly, your Kubernetes journey becomes very smooth. Of course. Now see this carefully. In Kubernetes, a pod is a wrapper around one or more containers. If you see in the right side of the image manifest file, inside this pod manifest file, under spec, we can have one main container, one or more sidecar containers. This is where the actual container which runs your application is called the main container, and the supporting containers are called sidecar containers. Basically, all these containers share the same network and they will share the same storage, runs on the same node. Okay, that is where Kubernetes pod becomes powerful. So why multi-container pod? Now in Kubernetes there are a lot of objects. We have objects for managing application deployment, and we also have objects for administration part, and even we have some other objects for load balancing purpose. But as of now, we will focus only on objects needed for running or deploying your applications. So later we will focus on the administration part. Despite of having multiple objects, pod is the base. So here we are running two containers inside one pod, one for the main applications, another one is sidecar container to help the main container. Logically, there is nothing special visually, but internally Kubernetes is managing both containers together. So let's see that actual manifest file of the pod. See, this is the code for multi-container pod. So here the apiVersion we define and kind we defined as a pod, and metadata, then name of the pod, and these are the labels. We'll discuss later why we need to use the labels, and the actual part which is called spec. And we already discussed why restartPolicy is required. If the container is failed, if the container is not started, if something is happening for that container, it will try to restart. So, and then coming to the containers, Ubuntu image is used for the main container. So this will take as a Ubuntu latest image, and CentOS 7 image version 7 will be used for the sidecar container. Both are running infinite loop. Every 15 seconds it will print the message. That means it will print the logs. So as you know, this is the startup command. It is running in infinite loop. Okay. So this is where you clearly understanding multiple containers inside a single pod. Now let's apply this part. kubectl apply -f tester.yaml. Now the pod is created. kubectl get pods. Now let's check the pod status. It is creating. kubectl get pods -watch. Now see, it initially it's showing container is creating, and even it's showing 0/2. Okay, this means Kubernetes is pulling the images and creating the containers. After a few seconds, if you run this command, so Now you will see there are 2 by 2 status is running. Okay, so which clearly means both containers are running successfully. So right side 2 means in this sample pod total containers are 2, and left side 2 means so 2 containers are in ready. That means it is up and running. In initial also, if we enter that kubectl get pods, total containers 2 and ready containers are 0. That means it's trying to create. Okay. Now let us describe the pod. Kubectl describe pod sample pod. Okay. So now see here, the important point is events. Now pod assigned to the node, this is the first line, it is assigned to the node. Okay, and then images are downloading. See here, pulling the image and successfully pull the ubuntu. So the first main core container using the ubuntu image, so that is where creating the main core container, started the main core container. Then pull the CentOS 7, and once the CentOS image is pulled, which is used for sidecar container, created the sidecar container, started the sidecar container. So after that, if we go and see here pod name and default namespace, we'll discuss about that in future, what is the namespace under. Then we discussed containers. This is the main core container. What is the container ID, image ID, and what is the image used for. Then after that, so this is the startup command we used. This will running on infinite loop. Then we used one more container. So this is called sidecar container, and here is the container ID, image ID. So this is where Kubernetes internally handles the container life cycle. So we will discuss the container life cycles also. What is the container life cycle? Okay, so that means it will pull the image, it will create the container, it will start the container. If it is not started, it will try to restart the container. So these are called container life cycle. We will discuss more on that. Now let's see pod logs. So kubectl logs -f sample pod. So it is asking which container logs do you want. So defaultly the main core container is showing. Here it is asking which container log you want. That's why we use -c option. Okay, so now see kubectl logs -f sample pod -c means it's a container. Okay, if we give main container, it will give the main container logs. Okay, for sidecar container logs, you can use instead of main container, sidecar container. See here, it is printing. So this is where you clearly understand how Kubernetes separates the logs as per the container. Okay, and if you want to go inside a container, we can use exec command, like how we are working with the Docker same way. Okay, kubectl exec and sample -pod -c main container, okay, -it --bin/bash. So this is the command. We can go to inside the container, or if you just want to run the command without entering this container, there is a one more command also will be there. So ps-eaf, if you can enter, see here, this is the startup command we use it for. You can go see, this is the main container. And if you came out and if you just want to run the command without entering inside the container, you can use kubectl exec sample pod --ps space eaf. Okay, see here, without went into the inside of the container, it is running. So basically Kubernetes gives full control over each container inside the pod. Okay, so then if you want to delete the container pod or containers, we can use kubectl delete -f. We can give test.yaml, this is the one command, or you can give kubectl delete pod sample pod. This also should be deleted. So this will be deleted, both the main container and the sidecar containers are deleted together. Okay, so that is where pod lifecycle management becomes very clear actually. Then coming to the conclusion, so today we learned what is a pod, why multi-container pods are used, so what is a main container versus sidecar container, and we have seen couple of commands like logs, exec, describe, delete, okay, and watch. Okay, so those are the commands we have used. If you understand this concept, pretty much Kubernetes becomes easily eventually. So in the next class we will come up with multi-container pod with some other examples, how to add the properties for the particular pod and how to map the port mapping. Okay, so we will discuss this going forward. Okay, so if this video helped you, could you please like, share and subscribe. Comment below if you want any real-time DevOps projects, because that is where real learning happens. See you in the next video. Thank you very much.